So this is the setup as you have seen it before. So this is basically a schematic of the setup that we saw inside of the lab. So you see we have the TDS system where the sample is put in the way of the terahertz wave and probed therefore by the terahertz wave. So basically the terahertz is just there to probe the sample. It doesn't interact with the sample or anything, but it's just there to probe the sample. And this sample is a special sample in some sense because it is engineered such that it is ultra strong. Basically the cyclotron transition of a two-dimensional electron gas is ultra strongly coupled to the terahertz cavity. The terahertz cavity in this case is such a resonator, was very similar to what Giancarlo was using. Is a resonator which is highly sub-wavelength and can confine the light in a very sub-wavelength volume, if you want. And by confining the light in a highly sub-wavelength volume and having quantum wells which confine the electrons, so the matter part also very strongly, ultra-strong coupling can happen between them. And this ultra-strong coupling is revealed by the fact that basically the matter part, which would be the cyclotron transition, in this case it would be this line, and the light part, which would be the cavity mode, which would be something like this, split. So they kind of hybridize, if you want. It's like in quantum wells or wherever where you have two levels or two energies that cross. If they couple to each other, then they split. You cannot have the same energy for both states, and they split and they form kind of anti-crossing, which is this type of behavior, and then you have a certain split between them. And by how strongly they anti-cross, this is a measure for how strongly you manage to couple the electron part or the matter part to the photon part, which is the metamaterial cavity. So this system has been realized in collaboration with people from Italy. So they did the samples and we probed them in, or some colleagues of mine, they probed them in our TDS system. So for doing this kind of probe, that's why I was saying we don't really need high power terahertz transients. We don't really need high power, but we need a very good detection of the terahertz transients. And yeah, so this is why again we are interested in zinc telluride crystals, which are other performing very well. Yeah, and then